45, 45, 90 special right triangles. They're both isosceles, so they're going to have, each one's going to have one pair of congruent sides. We're going to try to find the unknown lengths, which is x and z, and in order to do this, we're going to use Pythagoras' theorem. Which I just set up. Now, 4 squared is 16, 16 plus 16 is 32. I'm going to transpose this equation, the one on the left, because I like the x's to be on the left side. So now I'm going to take the square root of both sides, because ultimately we're trying to find out what x is. And we wind up with x is equal to plus or minus the square root of 32. We can disregard the minus because we're talking about length and you cannot have negative length. So we're going to simplify this radical. 32 is 16 times 2. The square root of 16 is 4. 2 has a square root, but it's irrational, so we're going to leave the 2 on the inside of the radical. And we wind up with 4 square root of 2. And now if we go back up here, we're starting to see this plot, or whatever you want to call it, unfold. So we're seeing 4 square root of 2, it looks like the hypotenuse is a square root of 2 times longer than each leg. Okay, so this is 4 square root of 2. And now we're going to solve the one on the right. The right, this time we have 4 square root of 2 as the hypotenuse. And we're going to just add up the z squareds, and we're going to have 2z squared is equal to 4 squared is 16, square root of 2 squared is 2. And now we're going to divide the 2. Divide the 2. We could just cancel that 2 out. And these cancel. And let's go ahead and finish this equation. And we have z is equal to 4. Again, we're going to disregard the negative because we're talking about length, and length cannot be negative. So that means z is 4. So that's 2 ways of proving that with the 45, 45, 90 special right triangle, the hypotenuse is always a square root of 2 times longer than each leg.